right, in this question, I am given a base, a strong base, and an acid, a strong acid. So it's an acid plus base problem. It doesn't say neutralization or titration, so I know that in this case, I'm going to have leftover either of the OH or the H. For every hydrogen that I have a hydroxide to pair with, those things cancel out, neutralize each other. But whatever I have more of, whoever wins that I have extra of, that's going to determine if this solution ends up being acidic or basic. To do that, I need to get to moles of H from the acid, moles of OH from the base. So my acid molarity is moles over liters. When I find the moles, it will be of HClO4, of the acid. But because the acid is in a 1-to-1 ratio with the hydrogen, this is also my moles of H+. If you want to see an example of what I mean by that 1-to-1 ratio, I believe I did it in problem 1C. My base molarity is moles over liters. So my moles of my calcium hydroxide, my whole base, are 0.06. Calcium hydroxide is not 1-to-1 with hydroxide, so I can't just say this equals my hydroxide. Instead, I do a proportion. For every 1 calcium hydroxide, there are 2 hydroxides. You can probably see this relationship just from looking at 1 calcium hydroxide. There are 2 hydroxides in it. Or you can dissociate your calcium hydroxide and balance and see 1 calcium, 2 hydroxides. Then I can use a proportion for moles or molarity. What I have the moles of is my calcium hydroxide, so I'd want to find the moles of my hydroxide. Cross multiplying this, X is going to represent my moles of hydroxide to be 0.12. Now, comparing my moles of hydrogen to my moles of hydroxide, there's more hydroxide. So once I figure out how much more, I'll be able to find how much OH didn't get neutralized by the acid. So I have 0.04 moles of OH that's left in this combined solution. So since the solution's combined, let me go over here, I can find the hydroxide molarity by taking my moles of hydroxide that are left in this combined total volume of 0.2 and 0.3. My hydroxide molarity is 0.8. If I negative log hydroxide, I will have POH to be 1.10. Subtracting that from 14, I get my pH. It should be a basic pH since what I had left over, what I had more of, was the hydroxide.